I'm Mark Burley. I'm an SE manager at Arista Networks. As we've seen, data centers have grown from very humble beginnings of tens or hundreds of servers to truly massive deployments of thousands, tens of thousands, or hundred thousands of servers. We've overcome many, many challenges, whether they have to do with link speeds or virtualization. We've provided tools to the end user to allow the end stations, the switches themselves, to monitor and react to certain situations, proactively monitoring and alerting the operations teams to when there's critical problems, and being able to proactively react to these issues if you so desire. We call this Advanced Event Monitoring. Advanced Event Monitoring, or AEM, is comprised of multiple tools: Event Monitor, Event Manager, the CLI Scheduler, and various Linux tools that reside in the Linux subsystem of Arista EOS. Event Manager allows the end user to monitor what's going on in the network and react to network events. Say when a device boots, to run certain scripts to make sure that it has connectivity. Or when an interface goes up or down, execute certain CLI commands based on that interface going up or down. So say an interface to an upstream switch goes down, you may want to bring a corresponding interface down, or you may want to change, say, the VRRP priority to switch the default gateway over based on this network event. With Event Manager, you can do that. Event Monitor allows us to proactively collect every change to the MAC address table, the ARP table, and the route table in the network. And we collect literally every event, no matter how quick they happen, and we store them on a SQLite database on the switch itself. So now, when a user reports a problem, you can go back in time and see what the MAC address table looked like, what the route table looked like, or if there was a valid ARP entry for that host. Having these critical pieces and being able to replay the network to the time of the problem can give us key indicators as to what was happening at that time. And being able to find out these key indicators allows us to determine, is this a true networking issue, or does this problem reside in the application stack? Combining that with the CLI scheduler, we can now run scheduled jobs, say every 1 minute, 5 minutes, or 15 minutes, to collect other data and analyze it. And if a problem is found, we can then send an SNMP message, a syslog message, an email, pretty much anything you want to send, we can send to alert the operations team that there is a problem. You're no longer restricted by certain MIBs or certain variables that we expose as a vendor. Anything that's available via the CLI, you can grab, you can collect, you can analyze, and you can alert on. In addition to the tools I just mentioned, you have full access to the Linux subsystem. Using this Linux subsystem, you have access to any tool that's common on a Linux server. You could do everything from a TCP dump to look for control plane traffic. You could have access to any scripting language that you so desire. So you can now grab this information, parse it in any familiar language that you want, and then export the data. Thank you for taking the time to watch this video.